Hello, welcome to this video. In this video, we are going to implement a physical memory manager for our kernel. If you remember, a few videos ago, we used the BIOS interrupt 15 to get a memory map of our system. If we run QEMU with the M option and 4096 as value, we basically get a system with 4 GB of RAM installed, emulated. And if we run our memory map, we see that there is a region of memory here with type 1, which means that we can use it, and it's almost 3 GB. I will show you the math that I used. So it's the perfect region to implement our physical memory manager. So let's go. We're going to do it by using a bitmap implementation. This means that we're going to use an array of bytes, and each bit in that array is going to represent one memory page. It's a very performant implementation. Each page will be 4096 bytes. Here we have the base and our limit that we took from our memory map, and here is the math that we calculate how many gigabytes is going to be. Basically, we subtract the base from our limit, and we get this huge number in decimal or this number in hexadecimal, which in gigabytes is almost 3 GB. And here I have implemented some macros that are going to make our lives much easier. First of all, here we calculate the number of pages. It's a very simple calculation. The subtraction above divided by 4096. Here we set our memory bitmap, which is the number of pages divided by 8, and here are our macros. The bitmap index macro will give us the byte that includes our memory page, and the bitmap offset will give us that particular bit in that byte that represents our memory page. Then, by using the OR operator, we set this the bit that represents this page to 1, which means that this page is used. Then, with the combination of the AND operator and the reverse, we basically make it again into 0. We clear it, which means this page is free now. And here we test with the AND operator if that memory page is used or not. Then we have here some functions that use the above macros. Mark page as used, mark page as free, and is page free. Now here is the function that allocates and returns the address of a memory page. We start looping through our all pages, and if we find a page that is free, we mark it as used and we return its address according to the offset of our memory base. Otherwise, we return null. In the future, we're going to implement an error handling system, and we're going to print something on the screen if something goes wrong during allocation. Here we have our free page function, which takes the address of a memory page, and after we make it into a number and we subtract it from our usable memory page base and we divide it with the page size, we get the place in our bitmap, and that's why we have these macros. They are going to set it free here. And then we have the initialize function, which sets all pages as free. Now, let's go to our kernel.c file. Let's initialize our memory manager and let's allocate space for two memory pages. If either of them has something wrong, no memory is allocated, we will print this string on our screen. Something went wrong. Otherwise, we are going to free both pages and we are going to write hello on our terminal. So let's make clean, let's run QEMU, and let's enter into protected mode. And we see hello printed on the screen, which means everything is working correctly. Thank you very much for being here. If you have any questions, I will answer in the comments. I will try to make videos more often. Thank you very much for being here.